In this section on functions and graphs, I want to talk about something that's called the difference quotient. The difference quotient is an important ratio or fraction to know how to find and simplify, and it is going to play a role later on in understanding something that's called the rate of change of a function over a given interval. Let's talk about how the difference quotient is defined. We have two key words here. Difference, that means subtraction. Quotient means fraction. So the way we define this, if we're given a function, f of x, the difference quotient is defined as f of x plus h minus f of x over h. So here's your difference, that's your subtraction part. And since this whole expression is a ratio or a fraction, it's a quotient, that's division. That's where we get the expression difference quotient. Now keep in mind, you can never divide by zero. Zero can never be a number in the denominator of a fraction. So when we define this difference quotient, we just have to make the distinction that h can never equal to zero. This has nothing to do with how you work the problem out. It's just something that has to be expressed when you're talking about the definition of a difference quotient. Now let's talk about how we actually simplify a difference quotient. So here's my first example. For the function f of x equals negative 3x plus 2, find the difference quotient f of x plus h minus f of x over h, where h is not equal to 0. We're going to look at this in pieces. Let's look at f of x plus h. So this is just the first part. We're going to take our function, and everywhere there is an x, we're going to replace it with x plus h. Now the way I'm going to do this, so it'll be easy to keep up with what's going on, I'm going to rewrite the original expression here on the right side, and instead of this x, I'm going to put an empty set of parentheses. So it's going to look like this: negative 3, open parentheses, plus 2. Now, what goes inside of our parentheses? Our x plus h. So negative 3 times x plus h plus 2. Now let's just simplify this. Here all we can do is distribute our 3 through parentheses. So that's going to give us negative 3x. Negative 3 times positive h is negative 3h. Bring down our 2. So this is the first part of our difference quotient. Now let's look at the second part. Let's look at our f of x. F of x is nothing more than the original function itself. F of x is equal to negative 3x plus 2. So here we have our second part. So we have our f of x plus h minus f of x. Now let's put this together in our difference quotient. Our f of x plus h minus f of x over h is nothing more than negative 3x minus 3h plus 2. That's our f of x plus h part. Minus, now this is where you have to be careful. Students make sign errors on this part a lot because of grouping symbols. I'm getting ready to subtract an expression from something else. So what I need to do is make sure that this second part that I'm getting ready to subtract, my f of x, always put it inside of parentheses. So the f of x is the original function, the negative 3x plus 2. So that's what goes inside of parentheses. Negative 3x plus 2. Now I need to put this over h. Now in terms of the actual difference quotient, we're done setting it up. all that we need to do now is simplify what we have. So what I'm going to do is get rid of my parentheses here by distributing my negative sign through the parentheses. So when we rewrite that, we get our negative 3x minus 3h plus 2, and this is going to become plus 3x minus 2 when I distribute. And I need to put this over h. Let's look at our numerator and see if we have anything that can simplify. Notice we have a negative 3x and a positive 3x. They cancel each other out. We have a positive 2 and a negative 2. They cancel each other out. In my numerator, I'm left with negative 3h. And then that's still over h. But notice here I have a common factor of h in the numerator and denominator. They cancel each other out. And I'm left with negative 3. So that's my answer. When I simplify this function using the difference quotient, when I find a difference quotient for that function, this is what I get. I get negative 3. Let's look at another example. For the function f of x equals negative 2x squared minus x minus 2, let's find our difference quotient, f of x plus h minus f of x over h. So let's look at our f of x plus h. I'm going to do exactly the same thing. I'm going to take my original function, and everywhere there is an x, I'm going to put an empty set of parentheses. So I have 2 parentheses, that's where my x is located, squared, minus, I have another x in this expression, so I need parentheses for that as well, and then I bring down my minus 2. Now what goes inside of the parentheses? It's the x plus h. So I rewrite this by placing my x plus h inside of parentheses. Now here's what you have to be extremely careful of. Here is where a lot of students make errors. Go back to your basic algebra when you're squaring a binomial. What we're going to have to do to simplify this, we need to multiply this out. 2 times x plus h squared. That x plus h squared actually means I need to go through the FOIL method on this x plus h. So let's go down here to the bottom of the page and do this. X plus h squared actually means x plus h times itself. When you go through the FOIL, you're going to have x times x times h times x, and h times h. And that's going to give you x squared plus xh plus another xh plus h squared. Combine your like terms right here in the middle. You get x squared plus 2xh plus h squared. So this part of the problem, just this part, the x plus h squared, comes out to be this green part, x squared plus 2xh plus h squared. So what I'm going to do is bring that down. So that's 2 times all of that I got when I multiply this out. But I still have this part of the problem that I need to bring down. So I have distribute my sign through, so that's minus x, and that's minus h. And we bring down our minus 2. We're still simplifying just our f of x plus h. I need to distribute my 2 through parentheses. I get 2x squared, and 2 times 2xh is 4xh. 2 times h squared is 2h squared minus x minus h minus 2. Now, I'm done with my f of x plus h. So this part right here, f of x plus h, is this, all of this in the yellow. This won't simplify, and there's nothing that I can cancel, nothing I can combine. Now let's look at the second part. Let's look at the f of x. F of x, remember I told you that's nothing more than the original function itself. So f of x is 2x squared minus x minus 2. Now I need to set up my difference quotient. F of x plus h minus f of x divided by h. Our f of x plus h is all of this that's in yellow, 2x squared plus 4xh plus 2h squared minus x minus h minus 2 minus, remember what I said about parentheses. This f of x needs to be in parentheses. So that's going to be our 2x squared minus x minus 2. And then we put all of this over h. From here, it's just a matter of simplifying everything. I need to distribute my negative sign through parentheses to get rid of them. So when we do that, we get 2x squared plus 4xh plus 2h squared minus x minus h minus 2, and this becomes minus 2x squared. That's going to be plus x, and that's going to be plus 2. And then we put that over h. Now let's see if we have anything that will cancel out. We have a positive 2x squared and a negative 2x squared that will cancel. We have a negative x and a positive x. We also have a negative 2 and a positive 2. That's all we have that will cancel. Let's look at what we have left. We have 4xh, we have 2h squared, and we have minus h. Now notice all three of these terms in the numerator have an h in common. So what I need to do is take that common factor of h and factor it out of my numerator. When I factor the h from 4xh, it just leaves me with 4x. When I factor an h from the h squared, from the 2h squared, it just leaves me with 2 and that other h. And when I factor h from itself, I'm left with 1. So now I see that I have an h here in the numerator and 1 in the denominator. That will cancel, and I'm left with 4x plus 2h minus 1. And that's our answer. So the difference quotient is really not difficult. You just have to keep up with where you're plugging things in and be careful with your signs. Remember, if you have the square of a binomial, you have to go through the FOIL method. You have to distribute, collect your like terms.